going to introduce a new word here, acceleration, right? To help describe motion. Now, acceleration is the symbol A. Now, there's a little typo here. It's actually a vector, so you should have an arrow. So acceleration has direction. So the definition of acceleration, it's the rate of change in velocity. Right. Now we can have a change in velocity in three different ways. You can have an object changing its speed, either speeding up or slowing down. That'll give you a change in velocity. Or you can have a change in direction. That would change its velocity as well. And finally, a combination of the two. Right? Change in speed and change in direction could result in a change in velocity. Now, something to be careful about is that two objects with the same change in velocity can have different accelerations. You may be wondering, why is that, right? Now, acceleration is not simply change in velocity, but what it is the rate of change in velocity. So the word rate in science is the amount of time it takes for a change to occur. So acceleration is the amount of time for the change in velocity to occur, right? So even if two objects have the same change in velocity, acceleration can be different because it can take a different amount of time for that change to occur, right? For example, if you have two cars, a fast car and a slow car, right? And they're both racing to 60 kilometers an hour, right? The faster car is going to have greater acceleration, right? They're both starting off at 0. They're both ending up at 60. So the final and initial velocities or the speeds are the same. What's different is the amount of time. The faster car did that change in less time. So it's going to have greater acceleration, right? So there's two types of accelerations. We can have positive or negative acceleration, right? So as soon as you say positive and negative, what is that referring to? That refers to the direction, right? So the direction of acceleration is the same as the direction of change in velocity. So if change in velocity is positive, so is acceleration. If change in velocity is negative, so is acceleration, right? Now let's link up the last page to the statement here, right? So if we have positive acceleration, here's an example, right? So we need to have a positive change in velocity. So a car speeding up in the forward direction, right, would be an example of positive acceleration, right? So let's break this down, right? The forward direction by default is positive. That's what we use a plus sign for, right? If you're speeding up, right, so you're going from 3 to 6, 6 minus 3 gives us positive 3. Our change in velocity is also going to be positive. So if our change in velocity is positive, our acceleration is also going to be positive, right? This example of negative acceleration would be a car slowing down in the forward direction. All right, so let's break this up. The forward direction is still positive with a plus sign, right? Slowing down is referring to a negative change. Now, if you have trouble imagining that, you can think of change in velocity is equal to your final minus your initial, right? And suppose we're initially going at 9 meters per second and we slow down to 6 meters per second. So our final is 6. Our initial was 9. We slowed down and our change is negative 3 meters per second, right? Slowing down, negative change, right? So if the change is negative, that means the acceleration is also negative, okay? Now, another word to describe the situation where acceleration is in the opposite direction of velocity, right, is called deceleration. So you probably heard of that. Deceleration. Right.